this video is based on the Reptile search algorithm. In this video, we will try to understand what is this algorithm all about, how it is working, various steps used in this algorithm, and mathematical models for the hunting, prey and circling, position update, and other activities. First of all, as you can see here, Reptile search algorithm is the nature-inspired, population-based Meta-heuristic optimization algorithm. This is the recently proposed and powerful Meta-heuristic optimization algorithm. It is inspired by the behavior of reptiles. This algorithm mimics the hunting behavior of the crocodiles in the real life. As you can see here, we have different types of reptiles. Reptiles are the cold-blooded animals, and this algorithm is inspired by the behavior of crocodiles and their hunting methods. In reptile search algorithm, different hunting methods used by crocodile are used to find out the optimal solution for the different optimization problems. As this algorithm is inspired by the crocodile behavior, so first we will try to understand few facts about crocodile so that we can easily understand how this algorithm is working. Crocodile are the biggest reptile and closely related to the dinosaurs. Saltwater crocodile are considered as the biggest reptile in the world. Crocodile ancestors were even much bigger. Here you can see crocodile diet. They can eat birds, fishes, mammals, other reptiles, and their predators are leopard, jaguar, anaconda, and other. Crocodiles are extremely fast in the water. Their swim speed is 35 km per hour and their lifespan is 60 to 70 years or even more. Depend on the different species. We have 13 different species for the crocodiles and their location in the America, Africa, Asia, Australia, but they are not found in the Europe. Crocodile weight is up to 18 kg to 1200 kg. Crocodile bite is the strongest bite in the world. Human jaw can apply 100-pound pressure per square inch, but crocodile jaw can apply 5,000-pound pressure per square inch. That's why crocodile bite is considered as the strongest bite in the world, because they can apply 5,000-pound pressure through their jaw. And as they are extremely fast in the water, on the land they can barely run up to 17 km per hour and they can hold their breath underwater. Now you can see here in this algorithm, crocodile behavior is divided into two main phases: exploration phase and exploitation phase. Exploration phase is the global search. Exploitation phase is the local search. Exploration phase is the global search. Here we will search the target in the search space. So here we will cover the entire search space. Different prey and circling methods are used here: high walking search method and valley walking search method in the exploration phase. In the exploitation phase, we have hunting coordination search method and hunting cooperation search method. So you can see here we have crocodile behavior and two main phases: and circling and then hunting. That is, first we will explore the search space and find out the target, and after that we will hunt, that is exploit. Here you can see we have different Steps used in this algorithm: first we will initialize all the important parameters, for example total number of iterations, population size, design variables and other. After that we will initialize the population for the n individuals in the search space randomly. After that we will check whether the current iteration is less than maximum number of iteration or not, and then using any fitness function we will evaluate the performance for the all agents, and then based on their fitness values we will select the best among all and then update the evolutionary census, and then for all the individuals in the current population we will update the hunting operator, reduce function, position difference, and then we will check whether the current iteration is less than or equal to maximum iteration. Here you can see we have the step 10. Now the main loop for reptile search algorithm start here. After that we have a condition if. So here you can see we have the behavior for the crocodile, encircle and hunt. So in this algorithm 4 partitions are done here. So in this algorithm we have the 4 different phases: high walk, valley walk, hunting coordination and hunting cooperation. So in this algorithm first we will check this condition. If here small t is the current iteration, capital T is the maximum number of iteration. If this condition is true then we will use high walk search method, else we will check this condition. If this condition is true then we will apply the valley walk search method, else we will apply the hunting coordination, else hunting cooperation, and then we will increment the counter in step 22. After that we will repeat the loop again whether the current iteration is greater than or equal to the maximum number of iteration or not. If this condition is true then we will again repeat the loop from step 11 to step 22. When the stopping criteria is met then we will display the best solution. Now you can see here we have hunting coordination, hunting cooperation, valley walk, high walk. Now we will try to understand the mathematical models for this. So in this algorithm first we will encircle the prey. Before encircling the prey first we will search that target in the search space and then we will attack. So here first we will encircle the prey, we will expand the search space, we will check whether the current iteration is less than or equal to maximum number of iteration divided by 2. After that we will attack the target when the search space converges toward near optimal solution. In this algorithm you can see here we have population. In real life we can easily distinguish between the prey and predator. We can easily distinguish between the crocodile and the target, but in this algorithm we have virtual environment. So we will initialize the population for the n individuals first, and then among all we will select the best agent is the target. So here you can see we have a target, this is the best among all, and all agents will update their position around the best solution. And after that we have hunting, that means attack. So here we will converge toward the optimal solution, that is the target, or you can say best solution. Now in this algorithm iterations, or you can say generations, are divided into 4 parts. Here you can see high walk, valley walk, hunting coordination and hunting cooperation. If this condition is true then high walk search method is used, else valley walk search method is used, else we will check this condition and then hunting coordination method is used, else this one, that is hunting cooperation. Now you can see this is the model for the high walk. Here you can see we have the best solution. You can see here in the search space where we have the n number of agents. Among all we will consider the best agent as the target, and we will update the position for all agents with respect to the best solution, or you can say best agent. And this is the hunting operator, and this is the exploration accuracy parameter, and this is the reduce function. Rand is any random value between 0 and 1. If this condition is not true, then we will use valley walk search method. Again, here you can see we have the best agent, that is the target, and this is the agent random position. Here R1 is the random number between 1 to n. N is the total number of search agents we have, and this is the evolutionary sense that we can calculate using this equation. Here R3 is any random value gain between 0 and 1. Capital T is the maximum number of iteration. Rand is the random number between 0 and 1. After that, we have the model for hunting coordination. As we know that crocodile hunt in team, they team up. Their hunting process is based on the coordination and collaboration. Coordinated hunting is the sophisticated form of cooperative hunting in the crocodile. While in the crocodile hunting process, each member have different role and they hunt accordingly. So here you can see we have the model for the hunting. If this condition is true, then hunting coordination as hunting cooperation. In the hunting coordination, we will update the position, that is the new solution, with respect to the best solution, and then we have position difference between the agents. Here M is the, here this one is the average position that we will calculate for all the agents. Rand is any random value, and then we have hunting cooperation. Again, we will update the position with respect to the best agent, and we have hunting operator, reduce function, and any random value. So in this algorithm, so you can see here iterations are divided into 4 parts. So you can see we will check if this condition is true, then we will use high walk search method by crocodile, else valley walk search method by the crocodile, else hunting coordination or hunting cooperation. So we have global search, that is exploration phase, local search, that is exploitation. It means we got the target and then we will converge toward the near optimal solution, that is the best solution found. So that's all about this algorithm. If you have any question, you can comment below, and thanks for watching this video.